Hello again. 2012 multiple choice questions. Calculator questions. 76. The graph of the function f is shown in the figure above. For which of the following values of x is f prime positive and increasing? So f prime is positive, means f is increasing. So f is increasing from here to there and from there to there. And then f prime increasing is the definition of concave up. So it's concave up from approximately there to there. So at what point are both of those things occurring? And the answer is E. There we go, just checking the answers again, which is a very good habit as you're going through these problems. Remember, the highlighted ones are ones that I highlighted myself just to make sure we discussed during class at some point. So let's see, which of the following is guaranteed by the intermediate value theorem? So we've got we have 2 points, 2, 10, and 4, 20. So f of x equals 13 somewhere. So this f of x equals 13 has at least one solution between 2 and 4. Since we changed from 10 to 20, that has to be true. F of 3 equals 15. Well, maybe, but f of 3 could be anything, really. It doesn't even have to be between 10 and 20. Because remember, intermediate value theorem, we can know there's a y value here and a y value here. And like, let's say that's 2 and 7. And we just know that the function will take on every value between 2 and 7. But it doesn't tell us whether or not maybe it goes way up and way down. We don't know. So f of 3 could actually be anything. So that one can't be right. F attains a maximum on the open interval, so that's not necessarily true. What if f just does this? What if it's just increasing the whole time, but it's an open interval? So remember, at endpoints of an open interval, there's no max or min there. F prime equals 5 has at least one solution. That is guaranteed by the mean value theorem, because we can do the slope between the 2 points and get 5, and therefore f prime of 5, f prime would have to equal 5 somewhere, but that's mean value theorem, not intermediate value theorem. And then f prime is always positive. We don't know if it is. It doesn't tell us anything about f prime. Yes, it changes from a y value of 10 to a y value of 20, so it increases in general. But if it's here, 10 here and 20 here, like I drew before, it could go, it could just start by going down and then come up like that. So there's an example where these 2 points exist. Number 78. Luke, close the door. Sorry, one of my kids interrupted me. All right, 78. The graph of that crosses the x-axis at one point. What is the slope of the graph at this point? So we have to find where this crosses the x-axis. I'll use Desmos for this. You guys, of course, need to know how to do this on your graphing calculator. All right, so we have e to the tangent x minus 2. We're looking just between 0 and 1, so I can zoom in here. So we're looking at this value right here. Do not round this value. I have to round it because Desmos only gives me 3 decimal places. I don't know how to get more. But make sure you don't round that. So it's 0.606. And then you can just use, it wants to know the slope of the graph at this point, so you can just do math 8 and use this value. Again, use the non-rounded version that your calculator gives you because you are using it for a future calculation. So when you math 8 it, you should get, what are we on, 78? The answer should be D. Oh, I didn't check 77. 77 is A, which we said. 79, a particle moves along the x-axis. The velocity and the acceleration are v and a. Which of the following gives the average velocity of a particle? Okay, average velocity. This would actually be average acceleration, because that's the slope of acceleration. That would be jerk. That's the slope between 2 points on the acceleration graph. This is, we're looking for average velocity. So you do the integral of velocity and divide it by its interval length, and that is the average value of a function. So 79, the answer should be B. Let's talk about what the other things might mean here. This means nothing. This is taking speed and dividing by 8. I guess that finds average speed, but we don't really ever do that. This is nothing, dividing by 1/2 when you do the integral from 0 to 8. And this is also nothing. That's just adding 2 velocities and dividing by 2. That's not how you find the average velocity. You got to sum up the infinitely many velocities that exist between 0 and 8. We have the graph of a derivative. Which of the following statements must be true? F has a relative min at -3. So the derivative changes from negative to positive. So that is a min, so that works. There's an inflection point at -2. No. Inflection points come from f prime at their maxes and mins. And the graph of f is concave down from 0 to 4. Concave down, the definition is decreasing slope. This is a graph of the slope, and it is decreasing from 0 to 4. And therefore, should be 1 and 3, which is answer E for number 80. And that is correct. Water is pumped into a tank. We know how much water is in the tank to begin with. We got 800 gallons right here. How much water to the next gallon is in the tank after 20 minutes? This should just be the integral of r of t dt from 0 to 20, and then add your initial amount, 800. Okay, you can just math 9 that. So as long as you type that correctly, you should get D. Okay. '82, we got f prime. If that's f prime, then f has a local maximum. So remember, maximums on the graph of f prime are where it crosses the x-axis from above to below. So from a positive slope to a negative slope. So let's see if we can find that here. We have the square root of x to the 4th plus 1 plus x cubed minus 3x. So we're looking for a local maximum where it crosses from above the x-axis to below, and it looks like it's at 0.35. So 82 should be C, which it is. '83. So this one gives us velocity, and it wants to know the distance traveled. This one's a little bit strange because it's the only problem I've ever seen like this, but distance traveled is area under the curve, and they've cut it into squares for us, so, or really they're rectangles, because they do have different dimensions even though they look like squares. And it says, which is the best estimate of the distance traveled? So we really just have to add these up. They all have a area of 10, so this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. This one's really close to 160. These two probably combine to be about 170, 180, really close to 190, 200-ish. So it looks like we're about 200. And 83 is D, 210. I never liked this question because I feel like you could reasonably get something closer to 180 and think that's the answer, but you just got to be somewhat careful, I suppose. We're given the derivative. Where is the graph of f concave down? So that is where f prime is decreasing. You could find the second derivative if you wanted and graph it and find where it's below the x-axis. But that's creating extra work for yourself because you can just use a calculator for this and use the given function. So we have e to the x to the 4th minus 2x squared plus 1 whole plus 1. Hey, I want plus 1 up there. Alright, I think I might have to do this. Some parentheses here. And then minus 2. All right, we're looking for where it's concave down. So this is f prime. So we want where f prime is below the x-axis, which looks like it's negative 1.354 to negative 0.409. Negative, yeah. And then it looks like 0.409 to 1.354. So C for 84. Oh, Los Santo, we're looking at the derivative graph. We want to know where the derivative graph is decreasing. And we're only looking between negative 1.5 and 1.5. So here to here, that's where the graph itself is decreasing. So that's from 0 to 1 for our x values. And it's decreasing from negative infinity until that point, actually until this point, sorry. So from negative 1.5, which is the endpoint of the interval that we're starting to look at, all the way up until an x value of negative 1. Let me get some of these points off here, if I can. Go away. That one down. All right, there you go. So an x value from, really it's decreasing from negative infinity to negative 1, so it's still decreasing then from negative 1.5 to negative 1. Okay, so that answer is D. The first time I answered the question, I was answering it as if it were f double prime, which is when you would look for when f double prime is below the x-axis, which I had said earlier, but then we were looking at f prime, not f double prime. Okay, here's a graph of f prime. Where is there a maximum? There's a maximum when it changes from above the x-axis to below the x-axis, which means f has a positive slope to a negative slope. So it should be at 1, which is answer C for 85, which is correct. 86. So we have f prime being positive. That means our value should increase as x increases. So x increases on all of these. So I've never seen a problem where they didn't just put them in increasing order, but make sure that they actually are. So we need a function that's increasing. This function is not increasing. That function is increasing. B is increasing. C does not increase because it decreases from there to there, so it's not C. That's not increasing. And this is increasing. All right, so we've eliminated 2 answers. Then, since the integral value is 0 between 4 and 7, that means the net area is 0, which means the graph had to be below the x-axis at some point and then above the x-axis. And so I had to do something like this in general. And therefore, here it never changed to a positive value, so the area couldn't be 0, so it's not that one. So it has to be B, and it can't be D because it never had a negative area. The graph was never below the x-axis. Therefore, you can't get a negative area, which means you can't get an integral value of 0. So what did we say? The answer is B for 86. All right, 87. Now we have a second derivative graph, and we want to know where it's concave down. So this is where it's below the x-axis, right there. So we're looking from negative 2 to negative 4. So it's negative 2 to negative 1, and 1 to 3. The answer should be E for 87, which it is. 88. All right, so we got a related rates problem going on here. It's using similar triangles also, which is a pretty typical type problem. There, come on. All right. So we got this guy right here who is 6 feet tall. We got a light post that's 15 feet tall. We'll call this X because that's the shadow, which is what we're trying to find is X prime. We'll call this Y. because that distance is increasing as the man walks away from the shadow. So we know y prime is 4. So we have y and y prime equals 4. So you can set up a proportion using similar triangles. 15 over x plus y equals 6 over x. Cross multiply, get 15x equals 6x plus 6y. That gives us 6y equals 9x, so 6y prime equals 9x prime. Y prime is 4, so you get 24 over 9 equals x prime. And 24 over 9 is 2.667, so B for 88, which, once again, we are correct. '89, we got acceleration, and we want to know the particle's velocity, so that is an antiderivative. So this is one of those problems where we know what something is at 0, and we're trying to find it at 3, so we do the integral from 0 to 3 of a of t, which you just do math 9, and that's going to give you some number, and that's going to equal v of 3, which is what we're trying to find, minus v of 0. And so use math 9 to get your integral value. Okay, that'll be some number. I don't know what it is. I'll let you find it. And then, so you have a number, some number from that, equals v of 3, and v of 0 is 5, so minus 5. So you just add 5 to whatever you got right here, and that will give you your answer, which should be E on 89. Which means this number that you should have got from your integral value is 1.710. Oh, sorry, hold on, 89 was E. Should be 6.710. '90. All right, so this one's kind of a unique question too. But notice how we have f of 2x inside an integral. So to me, that screams, oh, it's u substitution. So if we let u equal 2x, then du is, well, they use t's over here. I'll use it as u's, and then we can just change u to t at the end, just because you're used to u's, so it might look a little nicer as we're doing this. Du then is 2dx, okay? But we don't have a 2 inside this integral up here. So we're going to throw a 2 out here, and therefore 1/2 in front, okay? So that becomes 1/2 the integral of f of u du. And we know that that integral, which is equal to the original integral, so it's equal to 10. So we can multiply both sides of the equation by the 1/2 and get 20. But since we changed our variable, we change our bounds. It was 6 and 12, so when x was 6, using this equation, when x is 6, u equals 12. So that becomes 12, and when x was 12, u would be 24. So you end up with that integral right there, which is answer B. '91, we're given table values of f prime. Which of the following must be true? The graph is concave up. Just because, well, that would mean f prime is increasing, which it's not even increasing from here to here or from here to here. But even if it did increase the whole time on the table given, there's still a lot of data values, like infinitely many, that are skipped in between the data values we're given, and we still wouldn't have enough information to know if f prime is increasing the entire time. So we couldn't conclude that regardless. The graph of f has at least 2 points of inflection. So f prime decreased here, then increased. So f prime changed from increasing to decreasing. That's an inflection point. Then it's still increasing, and then changed to decreasing again. So this one is true. But let's talk about why the other ones aren't. F is increasing. F prime is positive based on all this data we're given. But again, what if at x equals -1, maybe f prime equals -100. We have no idea what f prime equals at -1. Just because all the given numbers are positive doesn't mean that it's always positive. So you gotta be careful with that. They always try to trick you with that. Must be true. F has no critical points. It could have critical points. We don't know. What if at -1 f prime equals 0? Well, that's a critical point then. We don't know enough values of f prime to determine that. F has at least 2 relative extrema. Well, based on this, the data we're given, f prime never changes signs, so we certainly don't know if it changes signs twice, which is what would cause a max or min. So the answer is B for 91. And finally, 92. All right, so we have a graph of x squared and square root of x. Here's square root of x. Here's x squared. They intersect at 1, 1. So this is square root of x. This one's x squared. So that region is like the bottom of some solid, and then jumping out of your iPad screen right at your face are a bunch of different size squares. And so we're trying to find the volume of that, which the volume of anything is we're going to sum up infinitely many volumes of these really skinny rectangular prisms as they're going to be, because the cross sections are squares, and each square is going to have a length from here to here, which is just square root of x minus x squared. So that's the side length of one square. You square that to get the area, and then you multiply by the thickness when we create another square. So this width right here is dx, and then you can just use Math 9 to get that final answer, which should get A if you do it correctly.